What we need to do now is get a formal definition of what a partial derivative is, which will also rely on differentiating from first principles. You can find this in section 8.1. That is the formal definition of a partial derivative. If we're looking at a function z that depends on x and y, we already saw that we can write the partial derivative of z in respect to x in this way. This is the Leibniz notation. This is the same as writing z x, which is also the same as writing in this compact notation f with this x on the bottom. This means the partial derivative of the function f in respect to x. And this is exactly the same as applying the operator, the partial derivative operator, to some function that depends on x and y. And this is what you do if you want to partially differentiate in respect to x. If you want to do it in respect to y, you have similar notations, but now with y, so that's dz dy. You can write zy fy, and this is the same as applying the partial derivative operator in respect to y of fxy. And I hope that the notation is absolutely clear. What we need to have a look at is what is a formal definition of these derivatives. And for that, let's make some space. And they're defined in a very similar way to differentiation from first principles. We define them as the limit when h goes to 0, the difference that the function depends on x and y, and therefore we write f of x plus h y minus f of x y over h. And you'll see why this is a partial derivative in respect to x, and why we say that we're keeping y fixed. Y is the same when we look at this difference. And in a similar way, we can write that the partial derivative in respect to y is given as the limit when y goes to 0 of f x y plus h minus f of x y over h. In this case, it is also clear that we're keeping x fixed because it's not changing. What we're changing is y. So we're looking at the variation of this function along the y direction, keeping the x direction fixed. There's even extra notations for partial derivatives that you can find in the lecture notes, and also here. Some of them even enhance the fact that you're keeping one of these variables fixed, and by putting them at the end of the brackets at the bottom right corner, what variable you're fixing. All of these are equivalent, and provided that you use them in a consistent way, you can use whatever you prefer. I will very often use fx and fy because they're convenient, and this is the notation that I'm also going to use when we go into directional derivatives, but you have the choice to use whatever you prefer. And I also try to use different ones just so that you understand that you can use anything you want, really, provided you're consistent.